Okay, so we're going to compute the image of the grid in front of us under the exponential mapping WZ to the Z. Now, pi, keep in mind, pi is like 3.14-ish. And so in particular, it's bigger than 2 and it's less than -2, or negative pi is less than -2. So this fits within our fundamental region. It's not important, but just observing it fits within the fundamental region. So what's going to happen? Well, we just saw what happens to vertical lines and horizontal lines. Let's trace out what's going to happen to our vertical lines first. And we're going to go out to e squared, which is a little bit less than 9. I'm going to put e squared there. And e is about 3, so e is going to go here. And we're also going to need to go to 1. E is about 3, so it's about a third of the way. All right. Okay, so let's first tackle what happens to this vertical segment where the real part is 0, right? So what this is going to get sent to is a portion of the circle of radius 1, because it's a vertical line and the real part's 0, so the radius should be e to the 0, which is 1. And we're going to go out not pi in clockwise and counterclockwise, we're going to go out 2. So we're going to go out sort of 2 is like 2/3 of pi almost, not exactly, but we're going to go sort of 2/3 of half rotation in each direction. So it looks a little bit more parabolic than it does circular, but pretend like that's a circle. Okay, so that is where this horizontal line segment is going to go. And similarly, this vertical, I will continue to confuse those for the rest of my life. The vertical line segment was going to go somewhere similar. So it's going to go out to an argument of 2. Oh, and then I didn't give myself enough space. Whew. So we're going to fudge it a little bit. Again, this looks more, pretend all of these are circular arcs. Use your imagination. So that's what's going to happen to our vertical lines. And then our horizontal lines are going to go to rays, where the argument of the ray is the height. So for example, this upper horizontal line has an argument of 2. That's here. Now, we're actually not going to get all of these points on that ray because we don't have a full-on horizontal line. We just have the portion of the horizontal line that should have, where the real part is from 0 to 2. So we're actually not going to get all lengths. We're just going to get the lengths from e to the 0 to e squared, where these are supposed to be a line. Okay, let's draw it like that. Similarly, this horizontal line down here is not going to give us all possible lengths. It's just going to give us the portion from e to the 0, which is 1, to e squared, which is what happens when this point over here is going to get sent to that point right there. All right, and then so we took care of what? The vertical lines and the upper and lower horizontal lines. Let's do the middle ones now. So this next one, going from top to bottom, has an argument of, well, a height of 1. So we're going to look at guys with argument 1. And again, it's only going to go from radius 1 to e squared. So 1 is about half, well, 1 is half of 2. So it's going to do something like that. This guy is going to be an argument of 0 and only going from radius 1 to 2, 1 to e squared. And the next one is going to have an argument of -1. So it's about halfway around. And so what we get as the image of that grid is we get sort of this segmented chunk of a pie, and that completes the example.